So today we're factoring trinomials, which are polynomials that look like this. But we're going to start today with the lead coefficient, the highest coefficient, or the coefficient of the highest power term being 1. So essentially we're getting rid of that a for today. We'll save that for the next lesson. Now, this factors into two binomials that look like this. It's going to sound complicated at first, but once we start doing some examples, it'll be pretty easy. Now, it factors into x plus some number and x plus another number, or it could be minus, depending on our signs. But we find those numbers with a very simple pattern. Those two numbers have to multiply together to be c, and they have to add up to be b. So basically what we're going to do is we're going to look for factors of c, our constant term, that add up to b, okay, our coefficient of x. It sounds, like I said, it sounds complicated, but it's not. I'll give you an example. X squared plus 5x plus 6. What factors of 6 add up to equal 5? What two numbers, when you multiply them, you get 6, and when you add them, you get 5? 3 and 2. Now, if you're not sure, just list what your possible pairs of factors are of 6, right? You got 1 times 6. Do those add up to be 5? No. 3 times 2. Do those add up to be 5? Yeah, there's your key right there. So that means this factors into x plus 3 times x plus 2. Now, just to give you a preview of tomorrow's, to make it a little easier when we get to the second part of this, I'm going to kind of show you how it gets there. What we could do is we could split that middle term, that 5x, into two pieces. Can we agree that 5x is the same as 3x plus 2x? So we're kind of uncombining like terms. Okay? And the nice thing is it doesn't matter what order you put it in. You could have done 2x plus 3x. It doesn't matter. Okay? We use a process called factoring by grouping, which sounds complicated, but it's not. It just means you factor in groups instead of the whole thing. We look at this first group. What do those two have in common? What's that? X. What are we left with when we factor x out? What do we get when we take x out of x squared? X. What do we get when we take x out of 3x? 3. Okay. So when we divide x squared by plus 3x by x, we get x plus 3, right? We use our distributive property, x times x is x squared, x times 3 is 3x. Okay. What can we factor out of the second pair? The 2x plus 6. 2. And what's left? X plus 3. See something kind of special there? Look at that. Now we've got two terms here, this one and this one, that both have an x plus 3, right? So you can factor out an x plus 3. Now if I factor x plus 3 out of the first term, what am I left with? X. If I factor it out of the second term, what am I left with? When I take the x plus 3 out of here, what am I left with? 2. Okay. That's the long way around. That's how that process works. Okay. And we're going to use that more in depth when we get to problems where this isn't 1, where a is not 1. We're going to use those more tomorrow. Today we'll use the shortcut. Essentially, we'll have trinomials that look like this. And we're looking for factors of 18 that add up to 11. What factors of 18 add up to 11? 9 and 2. So that factors into x plus 9, x plus 2. Or x plus 2, x plus 9. Doesn't matter. Make sense? So those are the two factors of the trinomial, x plus 9 and x plus 2. Those are the factors. All right, let's mess with the signs a little bit. They give you a whole pattern in the book on how to determine the signs. I don't think you really need to memorize that. I think with some practice, you'll get these pretty easily. So think about it. We're looking for numbers that multiply together to be positive 8 and add up to be negative, right? So if they multiply together to be positive, then either they're both positive or both negative, right? If two numbers multiply together to be a positive number, then they've either got to be both positive or both negative, right? But they've also got to add up to be negative. So should they be both positive or both negative? Both negative. That way they can add up to be negative. So what two numbers multiply together? Yeah. Negative 4 and negative 2. They multiply together to be positive 8, add up to be negative 6. Okay? Again, you can always list your factors. You know you got 1 and 8 and 2 and 4. Or negative 1, negative 8, negative 2, negative 4. And only one of those pairs is going to add up to negative 6. So our factorization becomes n minus 4 and minus 2. How are we doing so far? Good. All right. Now let's switch those signs again. So in this case, they multiply together to be a negative number. What does that tell you about their signs? They're opposite each other. One's positive, one's negative. But if they add up to be positive, what does that tell you? The greater one is positive, right? Because remember, when you're adding numbers with different signs, you subtract and keep the sign of the greater number. So our bigger one has to be positive. So if we list our pairs of factors of 15, we got 15 and 1 and 5 and 3, right? And as we said, the bigger one has to be positive, so we either have 15 and negative 1 or 5 and negative 3. Which of those pairs adds up to 2? 5 and negative 3. So that leaves us with y plus 5, y minus 3. Or y minus 3, y plus 5. You okay with that? All right, let's take a second. Let's do one on our own. Let's try m squared plus m minus 20. See if you can come up with a factorization for that. Okay, so we're looking for factors of negative 20 that add up to positive 1. So if they add up, or if they multiply together to be negative 20, then they have to have different signs, right? If they add up to be positive 1, then the bigger sign, or the bigger number has to be positive. So what'd you come up with, Tyler? 5 times negative 4. So that gives us a factorization of m plus 5, m minus 4, or m minus 4 times m plus 5. Good? Yes? Okay, the last part of this process is combining it with the equations with the zero product property. So if we have an equation like this, and we want to solve for x, our first step is going to be to get everything on one side. So how am I going to get everything on one side? Subtract the 18. Gives us x squared plus 3x minus 18 equals 0. My next step is going to be to factor. So I need to find factors of negative 18 that add up to positive 3. What have we got? 6 and negative 3. They got to have different signs to multiply together to be negative. And the bigger one has to be positive. So the factors of negative 18 would be 18 and negative 1, 9, negative 2, or 6 and negative 3. And that's the one that adds up to positive 3. So factors into x plus 6, x minus 3. With me so far? So here I can use my zero product property because I've got a product, right? Two quantities being multiplied together, and they equal 0. So that allows me to use my zero product property. How do I apply it? I set each factor equal to 0. X plus 6 must equal 0, or x minus 3 must equal 0. What does that give me for values for x? Negative 6 and positive 3. Subtract 6 from both sides, add 3 to both sides, gives me my two solutions. That make sense? How would we know if we got it right? Go back and plug them in up here and make sure both of them work. If we plug in negative 6, our left-hand side should come out to be 18. If we plug in positive 3, our left-hand side should come out to be 18. Okay. And we want to plug it in to this top equation. That way we know we did all the steps right. If we plug it into one of these middle ones, we only know that we did certain steps right. So let's make it a word problem. You are making banners to hang during School Spirit Week. Each banner requires 16.5 square feet of felt and will be cut as shown. Find the width of one banner. So we've got our banner set up like this. We want to know what the width of one banner would be, that W. Seems complicated, right? Well, if we take and put those two banners together, it forms a rectangle. That rectangle is W units wide. Okay, that's this length here, or this length here. What's the total length across the side? It's a little tough to picture. Let's think about it. Let's break it up a little bit here. One banner would take up this portion here. The other banner is going to take up this portion here. Right? And if we label some of our sides here, we know that those ends are W. What's this length here? That's 4 feet. What's this length here? 4 feet. What's this middle length? So what's the total length of the banner? Not 8W. Nope. Only got one W. But it's not 8 times W. 8 plus W. Okay, or W plus 8. Either way. Make sense? So how would I write the area of that rectangle? W plus 8 times W equals the area. Now, they told me how much area we're using to make this banner. What's the total area that we're using for this banner? One banner is 16.5. So 2 banners together is 33. Okay, that's a little trick they threw in there. So those got a total to be 33. All right. Now, our first step is to get everything all on one side, but we're going to combine that with our distributive property. So what do I get when I distribute?
W squared.
W squared, because W times W is W squared, plus 8W. When I move that 33 over, what does it become? Minus 33. So I'm looking for factors of negative 33 that add up to 8. Tyler. 11 and negative 3. You only have so many options for factors of 33. You got 33 and 1, and 11 and 3. We know that the bigger one has to be positive, smaller one has to be negative, and only one of those pairs adds up to 8. So we have W plus 11 times W minus 3. What does that give us for solutions for W? Negative 11, because if W plus 11 equals 0, W equals negative 11. And positive 3, because if W minus 3 equals 0, you get positive 3. Right? But only one of those actually fits this situation. Which is it? The positive 3, because you can't have a banner that's a negative 11 inches wide. Or negative 11 feet wide. Doesn't work. Make sense? Questions? All right.